Hello friends, welcome to my new data structures and algorithm in Java tutorial series video. Friends, in this tutorial we will discuss recursive post-order traversal of a binary tree in Java. So friends, what is post-order binary tree traversal? Basically there are three steps involved in doing the post-order binary tree traversal, and all these three steps are applied over each and every node of a binary tree. So if we take an example of a binary tree shown in the slide, then basically we start with the root node and we apply these three steps over the root node. So what actually we do is, in order to visit this particular node, first we actually visit its left subtree completely, then we visit its right subtree completely, and then we actually visit the node. So here if we want to visit the node 1, then we have to first visit its left subtree completely, and then we have to visit its right subtree completely, and then we can visit the node. And these three steps are applied over each and every node. So suppose we are on node 2. So in order to visit this node, what we have to do? First we have to visit its left subtree completely. Then we need to visit its right subtree completely, and then we can visit the node. So therefore here, before visiting the node 2, we have to first visit the node 4. Then we have to visit the node 5, and then we can visit the node 2. So here basically these three steps are applied on each and every node of a binary tree in order to do post-order binary tree traversal. So friends, in this tutorial we are discussing the recursive post-order binary tree traversal. Below you can see the algorithm for the post-order binary tree traversal. So we will demonstrate this algorithm using this binary tree here, and we will see how we can apply this algorithm on this binary tree, and whatever the output comes out, it will be displayed here. So friends, as this algorithm is recursive in nature, here you can see post-order method is again internally calling the post-order method. Therefore, this is a recursive nature algorithm. So in order to understand the recursive nature of this post-order method, we will maintain a call stack so that we come to know that which method is currently being executed and what is the route that is being processed. We will come to know about line number when we will actually discuss the post-order method. So friends, let's see the demonstration of this algorithm step by step. So friends, here you can see the root is pointing to the node 9, and when we call this post order we actually pass the root node. So to this post order we are actually passing the root node as 9. So friends, when the point of execution reaches this post order method, we know that on the call stack there will be one method by the name post order, and we also know that we have passed the root as 9. So therefore on the call stack there will be one method by name post order which will start its execution. Moving ahead, so friends, the first step we actually check whether root is equal to null or not. So if root is equal to null, we simply return from that method, and here you can see that this condition will act as our base case, because as we are calling this post order method and internally again calls the post order method, we need to provide a base case to stop the execution of this post order method, because if we don't provide the base case, post order method will again call post order method and it will go on calling each other infinitely. So this is the base case which is required in order to break the recursion, and we will see its significance later in the demonstration. So currently, as you can see, root is pointing to 9, therefore it's not equal to null. So therefore the condition in if block comes out to be false. And at the line number 5, we see it calls post order method again, and this time we are passing roots left, which is the node 2. So friends, as we discussed in our previous slide, that in order to visit a particular node, we have to first visit its left subtree completely, then we have to visit its right subtree completely, and then we can visit the node. So therefore, before visiting the node 9, we have to first visit its left subtree completely. So we are again calling the post order method, and we are passing root.left to it, which is nothing but the node 2. So here you can see when we had called this post order method, there was one method on the call stack, and inside this we are calling this post order method again. So when we call this post order method, we are leaving this post order method. So in order to keep the track of this post order method, we will update the line number here. So it would look something like this. that from line number 5 we are leaving this post order method and we are again calling the post order method with a root as 2. So once this line gets executed, we know that post order method will be called again, and this time this post order method will be called with the root as 2. So therefore the line of execution reaches to the post order method again, and we know that root will now point to the node 2. So now this method starts execution with a root as 2. Therefore we know that there will be one more method on the call stack. So here now this post order method will start its execution with a root as 2. Moving ahead, we will check whether root is equal to null or not. So here root is pointing to the node 2, therefore it's not null. So the condition in if block comes out to be false. And at the line number 5, we are again calling the post order method, and this time we are passing root.left. So here root left is nothing but the node 4. So why we are doing this step is because in order to process this node 2, we know that we have to first visit its left subtree completely, then we have to visit its right subtree completely, and then only we can visit this node. And we also discussed in our previous slide that all the 3 steps are applied to each and every node of the binary tree. So therefore before traversing the node 2, we have to first visit its left subtree completely. So therefore we are calling this post order method again with a root as 4, and we also know that we are leaving this post order method, so we will update the line number here, which is nothing but 5. So now point of execution reaches to this post order method with the root as 4, and we also know that now root will point to the node 4, and as this method will start its execution, there will be one more method on the call stack with the root as 4. So here now this post order method will start its execution with the root as 4. So in the first step we will check whether root is equal to null or not. So currently root is pointing to the node 4, therefore it's not null. So the condition in if block comes out to be false. And then on the line number 5 we are again calling post order method with the value as root.left. So friends, in order to process the node 4, we have to first visit its left subtree completely, then we have to visit its right subtree completely, and then only we can visit the node 4. Therefore we are again calling the post order method, and this time we are passing the value as root.left. So here root is pointing to node 4 and its left is pointing to null. Therefore now we are calling this post order method with a null value, and we also know that we are leaving this method from the line number 5, therefore we will update the line number here as 5. So the point of execution will reach to this post order method with a root as null. So therefore now root will point to null, and we also know that there will be one more method on the call stack by the name post order and whose root will be null. So now this post order method will start its execution with a root as null. So here first we will check whether root is equal to null or not. So currently you can see root is pointing to null, therefore the condition in if block comes out to be true. So therefore we have reached our base case. So we'll simply return from this method. So friends, as we return from this method, we know that this post order method is executed completely, therefore this method will be removed from the call stack. So friends, when this method is removed from the call stack, the call goes to its previous method which actually called this method with a root as null. And we also know that we had left this post order method from the line number 5. So the point of execution reaches to this node and we'll start our execution from the line number 5. Because at this line number we have actually left this method, so therefore we'll start our execution from this line. And we also know that when we had left this method, at that moment root was pointing to node 4. So therefore now root will point to node 4. Moving ahead. So friends, at the line number 6 we are again calling the post order method, but this time we are passing it a value as root.right. which actually makes sense because in order to traverse this node 4, we have to first visit its left subtree completely, then we have to visit its right subtree completely, and then we can visit the node. So therefore on the line number 5, we have completely visited the left subtree for the node 4. So now is the time to visit its right subtree. So therefore we are again calling the post order method and we are passing the value as root.write. So here root is pointing to node 4 and its right is pointing to null. Therefore we know that now we'll call this post order method with a null value. And we also know that as we are leaving this post order method from the line number 6, we need to update the line number here. So the line number becomes 6. So friends, point of execution reaches to this post order method and this time the root will be null. And we also know that once this method starts its execution, there will be one more method on the call stack with the root as null. So it would look something like this. So we know that root is null. So therefore now root will point to the null. Moving ahead, we will check in the if block whether root is equal to null or not. So currently you can see root is equal to null. So therefore we'll simply return from this method. And as we return from this method, we know that this method is executed completely. So this would be removed from the call stack. And the point of execution reaches to the post order which actually called this method. And we also know that we had left this post order method from the line number 6. Therefore the execution will start from the line number 6. And we also know that when we had left this method, root was pointing to the node 4. So therefore now root will point to node 4. Moving ahead. So friends, on line number 7, we will simply print the data associated with this root. So friends, in order to process the node 4, what we have actually done is, we have first visited its left subtree completely, then we visited its right subtree completely. So after doing this stuff, we are actually visiting the node 4. So we are simply printing its data on the console, which is 4. Moving ahead. So friends, at the line number 8, this post order method on the call stack will complete its execution. So this would be removed from the call stack completely and the point of execution will reach here. And we also know that we had left this post order method from the line number 5. So the point of execution reaches to the line number 5. And we also know that at that time root was pointing to node 2. So here now root will point to node 2. And we'll start our execution with this post order method. So friends, in the line number 6, we are again calling the post order method and this time we are passing root.write to it. So here you can see root is pointing to node 2. So we'll pass root.write, which is null, to this post order method. So friends, here you can see we are calling this post order method again with the root as null because root.write is nothing but null value. And we also know that we are leaving this method, so we'll update the line number here. And we know that line number is 6. So now line number changes to 6. So root is pointing to the node 2. Therefore now it will point to its right, which is null. Now this method will start its execution. So therefore there will be one more entry on the call stack with a root as null. Moving ahead. We'll check whether root is equal to null or not. So currently root is equal to null. So therefore we'll simply return from this method. So when we return from this method, we know that this post order method is executed completely. So therefore it will be removed from the call stack. And once it's removed from the call stack, the point of execution reaches to this post order method. And we also know that we have left this method at the line number 6. So we'll start its execution from the line number 6. And we also know that when we had left this method, root was pointing to node 2. So here root is pointing to null. So now it will point to node 2. Moving ahead. And at the step 7, we'll simply print the data associated with the root, which is nothing but 2. So friends, here you can see before processing of the node 2, we first completely visited its left subtree and we printed node 4, and then we visited its complete right subtree, which was actually null, and then we actually visited the node 2. So it printed something like this, 4 and then 2. Moving ahead. So at line number 8, we know that this post order method is being executed completely. So therefore this would be removed from the call stack. And the point of execution reaches to this post order method. And we also know that when we had left this post order method from the call stack, the line number was actually 5. So we'll start our execution from the line number 5. And we also know that root at that time pointed to the node 9. So therefore now root will point to node 9. And our execution starts from line number 5. So friends, here you can see that we are on node 9. And in order to visit this node, we have to first visit its left subtree completely, which you have actually done. And then we have to visit its right subtree completely. So now we'll start to move to its right, and then we can process this node 9. So we are again calling the post order method, and this time we are passing the value as root.right because we have to now visit its right subtree completely. So therefore you can see root's right is nothing but node 3. So we will be again calling this post order method with a root as 3. And we also know that we are leaving this method post order from the line number 6. So therefore we'll update the line number here. So now point of execution again starts post order method, and this time with the root as 3. So now root is pointing to the node 3, and we also know that there will be one more method on the call stack with the root as 3. So friends, now let's start the execution of this post order method with the root as 3. In the first step, we will check whether root is equal to null or not. So currently root is pointing to node 3, therefore it's not null. And at the line number 5, we will again call post order method, and this time we are passing root's left, which is nothing but the null value. So here, before processing of node 3, we know that we have to first process its left subtree, and then we have to process its right subtree. So in order to process its left subtree, we are calling this post order method again with roots left, which is nothing but the null value. So friends, we are leaving this post order method at line number 5. So we will update the line number here. And then point of execution will call this post order method again with root as null. So now root will point to null. And we also know that there will be one more method on the call stack with a root as null. So now let's execute this post order method with the root as null. So here we check whether root is equal to null or not. So currently root is equal to null. Therefore we'll simply return from this method. So once we return from this method, we know that this method is executed completely. So it will be removed from the call stack, and point of execution will reach to this post order method. And we know that we had left this post order method from the line number 5. So therefore we'll again start our execution from the line number 5 with a root as 3. So currently root is pointing to null. So now it will point to 3. So we are starting from line number 5, and now root will point to node 3. Moving ahead. So at the line number 6, we will call post order method again, and we'll pass the value as root.right, because in order to traverse this node, we have to traverse his left subtree first, which we have already done. So now is the time to traverse his right subtree, and after traversing right subtree, we can actually visit this node 3. So in order to visit its right subtree, we are calling this post order method again, and we are passing the null value to it. And we also know that we are leaving this method at line number 6. So we'll update the line number here. So now point of execution will start the execution of this new post order method with the root as null. So root is pointing to node 3. Now it will point to null. And we also know that there will be one more method on the call stack with the root as null. So let's start the execution of this post order method with the root as null. So we'll check whether root is equal to null or not. So currently root is equal to null. Therefore we have actually visited the right subtree for the node 3. So we'll simply return from this method. And as we return from this method, this post order method will be removed from the call stack and point of execution will reach to this post order method. And we know that we have left this post order method from the line number 6 with the root as 3. So we'll start the execution from the line number 6, and we know that at that time root was pointing to 3. So now root will point to node 3. So friends, we have visited the left subtree for the node 3 and we also visited the right subtree for the node 3. So now we can actually visit the node 3. So on the line number 7, we will simply print the data associated with this root, which is nothing but 3. Moving ahead. And once we reach the line number 8, we know that we have successfully executed this post order method. So this method will be removed from the call stack. And the point of execution will reach to this post order method. And we also know that we had left this post order method from the line number 6. And at that time the root was actually 9. So we are starting from the line number 6. And we know that we had left this method when the root was pointing to 9. So therefore now root will point to 9. Moving ahead. So friends, here you can see for the node 9 we have completely visited its left subtree and we have printed 4 and 2. Then we actually visited the right subtree completely and we printed 3. So now is the time to visit the node 9. So we are simply printing the data on the console for the root which is pointing to node 9. So now 9 will be printed on the console. And from the line number 8 we know that we have completely executed this post order method. So this would be removed from the call stack. And once this is removed from the call stack, we know that there are no more methods left to be traversed. So here we have actually successfully executed this recursive post order traversal to this binary tree, and we have printed its each and every node on the console as 4, 2, 3, 9. So friends, this was the demonstration of the algorithm. Now let's go to Eclipse and see the working code. So friends, in my previous tutorial, I had created one class by name binary tree, and we actually implemented the binary tree into this class. So in order to understand the implementation of this binary tree, you can watch my previous tutorials. So in this tutorial, we will actually code recursive post order traversal of a binary tree. So here I will create one method as public void post order. So this is the same method which we discussed in the slide. So this method takes in a root which is of type tree node. So first we'll provide the base case, which is we will check whether root is equal to null or not. So if root is equal to null, then we'll simply return from this method. So this is nothing but the base case because we are calling this post order method recursively. So friends, as we discussed in our slide, that in post order tree traversal, before visiting any node, we will first visit his left subtree and then we'll visit his right subtree and then we can visit the actual node. So first we'll visit the left subtree by calling root.left, and then we'll visit its right subtree by calling root.write. And after visiting the left subtree and the right subtree, we'll actually visit the node. So we'll simply print root.data on the console. So friend, this is the code for recursive post order binary tree traversal. So now let's test its working on the main method. So here in the main method, we'll first initialize this binary tree class, and then we'll create the binary tree. So in create binary tree method, we are actually creating the binary tree with few nodes, and these are the same nodes which you discussed in the slide. And we also discussed this method in my previous tutorials. So you can watch my previous tutorials in order to understand how we have created this binary tree with the few nodes. So after creating this binary tree, we'll actually call the post order method, and we'll also pass the root into it. So if I run the code now, so you can see it printed 4239, which is the same output which we discussed in the slide. So friend, in this tutorial we discussed about the recursive post order binary tree traversal. I hope you liked this video. Please like, comment, share and subscribe my YouTube channel. Thanks, have a nice day.